Good day, everyone. And first of all, thank you for providing this feedback about how our class is conducted. Today, I'm going to record 3 little videos about these issues. So, detecting ODE of the form dy dt is f of t, necessary condition for to recognize separable differential equations, and constructing an ODE with a specified general solution. But before I do that, let me review the textual feedback. Right? So, let me comment on this. Well, specifically, I want to comment on this suggestion. Right? So it says that for some questions, you need to know certain tricks to solve them, and the suggestion is that I should teach you those tricks in the lecture. So now the thing is that mathematics is not about memorizing how to solve different types of questions. Mathematics is about logical reasoning, is about finding patterns, and is about understanding abstract concepts, right? So what I want to say is that I'm not going to teach you those tricks how to solve questions, because I want to teach you how to invent those tricks to solve these questions. So which is why my answer to this suggestion is absolutely not. I'm not going to teach these tricks because I want you to invent those tricks. All right. And of course, you pointed out that questions are too hard, but mathematics is hard, which is why very often in future application exercises are going to be very hard. That's just because, you know, the subject is hard. Well, but most importantly, a lot of you wrote that there was not enough time to solve all these application exercises, and I agree with you, and the point is taken. So I promise you that we are going to try to manage our time better in future. All right. So with that being said, let me now continue with the first big issue. Is about detecting differential equation of the form where the right hand side depends just on t or just on y from the direction field. Right? So how can we see that from the direction field? So basically, this is about the direction field being invariant under vertical translation or under horizontal translation, or not being invariant under either one. But what does it mean? So let me explain what is invariance under horizontal translation. So invariance under horizontal translation means that if you have stamped your vector field and then you try to translate it to the left or to the right, then what you are going to get is exactly the same vector field as the one that's been stamped. So if, say, we try to move it to the left, then what we see is exactly the same thing. So it is invariant under horizontal translation. So if we try to move it to the right, same thing, all these vectors, if you move it kind of 1 unit to the right, then each vector is moved to exactly the same vector, and you cannot see where the origin, where kind of the two templates are. So the one that has been there and the one that is being moved. So this is invariance under horizontal translation. But at the same time, if, say, you try to move it vertically, then you see it's, you move it 1 unit vertically, but then it is not invariant under vertical translation, because when you move each vector vertically, then it does not get to exactly the same the same vector, right? So this is not invariant under horizontal translation. So it is invariant under it is invariant under horizontal translation, but not vertical. And whenever the vector field is invariant under horizontal translation, it means that, well, if you change t, then the vector field does not change. So therefore, the right-hand side is a function of just y. Now, here is an example of a vector field that is invariant under vertical translation, right? So because now, if we move it vertically, we get exactly the same thing. Or if, say, we move it down, again, we get exactly the same thing. But this vector field is not invariant under horizontal translation. So if you try to move it to the left, then you get something different. So, which means this is invariant under vertical translation. Sorry, it is invariant under vertical translation, yeah, but not horizontal. And since it is invariant under vertical translation, which means change in y, so change in y does not change the right-hand side of the differential equation. So therefore, the right-hand side of the differential equation does not depend on y and only depends on t. Well, and this vector field is not invariant under vertical or horizontal translation. So for example, if you try to move it to the left, you get something different. If you try to move it, say, upward, you get something different. So it is not invariant under vertical or horizontal translation, which means the right-hand side is a function of both t and y. Now let's look at the formula, the equations that generate this, and let me explain a slightly different way to see the same thing, right? So when you want to see whether the vector field is invariant under horizontal translation, what you are looking at is you need to look for whether all the vectors along the same horizontal line are actually the same, right? So you choose any horizontal line, and you see that all vectors along this line, they have exactly the same slope. So they're all the same. Or say this line, so along this line all the vectors are exactly horizontal, so along this line all the vectors are exactly the same, and so on. So if you check any horizontal line, then all the vectors along that horizontal line are going to be exactly the same. So which means that the differential equation is a function, well, has the right hand side that is only dependent on y, but there is no t there. So such a differential equation is called autonomous. Right, and here you have kind of a similar situation, but now all the vectors along every vertical line are exactly the same. So if you take any vertical line, all the vectors along every vertical line are exactly the same. So, and then it tells you that the differential equation has this form where the right-hand side is a function of just t. So it tells you that y prime equals some function of t, so which means that this is not really a difficult differential equation, so you can just solve it by a simple integration. So the answer is that y is the antiderivative of the right-hand side. And so for example here, you can easily imagine, right, so that the right-hand side is a quadratic function, so its antiderivative is going to be a cubic function, so the antiderivative is what is t cubed, and you can see that the t cube is a solution. And more generally, t cubed plus c is another solution. So the family of solutions is t cubed plus minus some constant. Okay, and well, this is a vector field that is not invariant either under vertical or horizontal translation, which you can see that if you can take some, I don't know, let's say horizontal arrows, right? So then the arrow here points kind of upwards, but this arrow points a bit downwards, so they're different. So arrows along this horizontal line are different, while same about vertical lines. So here, this arrow is different from this arrow. So since they're different, it is not true that all arrows along every vertical line or every horizontal line are the same. So which means that this vector field is not invariant under vertical translation or horizontal translation. So now let me summarize. So there are two ways to see that. So one thing is you can either imagine that you have a copy of your vector field is printed on paper, and another copy is plotted on a transparency, and then when you move the transparency to the left or to the right, so if after movement all the vectors coincide with the positions with the similar vector on paper, then you have your invariant. So if you are able to do this trick mentally, of course you're not going to have transparencies in a midterm test. So, but if you are able to imagine this, I think it is a good way to understand it. But alternatively, what you can do is you can just look for all arrows along every horizontal line or all arrows along every vertical line, and then you will see whether the vector field is invariant under horizontal translation or under vertical translation. Okay, so horizontal translation means if it is invariant under horizontal translation, then it means that it is a differential equation of the form y prime equals f of y. Vertical translation, it is a differential equation of the form y prime equals, say, g of t. In both cases, the differential equation is separable.